technology, and I was looking at an article on popular science, and I was like, wait a minute, the night vision technology here is a lot bigger than I thought it would be. And so I began doing research and found that there were a lot of issues with current night vision technology on the market. The majority of them involve weight, the weight of the devices, the cost of the devices, and the size of the devices. And after reading some interviews, I learned about a lot of complaints in military applications, actually, where after wearing night vision goggles for long periods of time, people began to complain of neck problems and injuries from having to wear them and look around for so long. And so I began looking into customer discovery because I wanted to see, like, I think I can build something that's smaller and more compact than this. So I began talking to people to figure out exactly what they would want to see in a set of smaller night vision goggles. So that led me to the four main groups that you can see on this page right here. I believe the first customers that I believe have shown the most promise at the moment are the power industry. You can use them thermal imaging equipment. That's the specific type of night vision technology I am pushing towards at the moment, for a variety of applications, mainly involving areas in the field. After actually talking to Will about what thermal imaging technology is used for at the moment, they're not usually used very often in power plants. It's more in the field for like first responders and finding transformers and power lines that are still energized and a variety of other applications. The second market that I'm looking into is law enforcement. After talking to a friend of mine who used to be a former police officer and is now pursuing his undergraduate degree, I found that thermal imaging and other night vision equipment in police offices is ridiculously expensive, usually costing about several $1,000s per unit, and oftentimes only having 3 or 4 specific sets for an entire department, which would be kind of bad for special operations. The third set of customers I'm looking at is the firefighting department, for obvious reasons, determining like where exactly the hottest parts of a fire are, or determining if there are people still in the fire, because the thermal imaging equipment can determine the difference between the temperature of the fire and the temperature of the human body. And then the last set of customers I'm looking at is the military, but these will be the last for reasons involving component quality, which I will be happy to go into more detail about after the presentation. So, I've told you about the customers, but what exactly is HeatSight? HeatSight is a set of currently thermal imaging goggles that is meant to be smaller, more compact, and inexpensive while providing comparable image quality. The developmental process started during first year. Here, I started actually with near-infrared technology, which is a type of night vision technology that is different, and I'll be happy to go into more detail after the presentation. I built 10 prototypes over the course of spring and summer, and then made the switch to actual thermal imaging back in fall of second year, and I went through 10 more prototypes. The first picture you see over here is my 9th prototype back when I was working on the near-infrared technology. And over here you can see this is the 19th prototype that I built actually last fall. And then, so I wasn't really sure about business stuff until actually this past fall when I entered the Pike Fellowship, which opened a whole new world of possibilities in terms of business entrepreneurship. So, let's see. When you compare the current iterations of HeatSight to other goggles, or other thermal imaging equipment in general, they are relatively lightweight, they are incredibly easy to wear. I actually have a couple of my earlier prototypes here. This is version, I want to say, prototype number 18, and here's prototype 19 in the flesh, so to speak. And so, when compared to other thermal imaging equipment, except for one, which I will go into more detail about in a minute, they are relatively light, they're easy to wear, they are affordable. Like, for the overall cost of building one of these prototypes is, a rough estimate is about $300, $400. I'll go into more detail about that after the presentation if you like. And they are ridiculously easy to use. You just put them in, you turn them on, and then you wait for it to boot up, and then it will start providing a live image feed to you. And the image quality is relatively comparable to some of the products that are already out on the market. That is one of the areas which I am looking to improve. To go into more detail about the product that I mentioned earlier, that would be competitive in terms of size. I was looking at the phone attachment, which some of you might be familiar with. There are two main ones, the Seek Thermal and the FLIR one. Those plug into a cell phone and use an app to overlay the thermal image feed with the camera feed from the phone itself. And I'm actually doing something similar with not these two prototypes, but the most recent one, which I do not have with me at the moment because when I was assembling it, it turned out to be flimsier than I thought it would be. So instead, I've got a really, really short video of it in action. Hopefully this actually works. Yes. There you go. That was it. So what you saw in the video was my latest setup. You've got display screen over here, and as you might have been able to tell, that was my hand moving around in the video, and that's my hand up there. Over here you've got the thermal camera and actual camera combined into a case that I 3D printed recently. And over here you have another still image, that image, that I took to show other in action. So, in terms of what I'm planning to do moving forward, I'm unfortunately not as far as robotics because this is a relatively new project. So my next steps forward are focusing mainly in terms of customer discovery, developing a set business plan, and upgrading the technology so I can get a minimum viable product out for testing, hopefully by the end of this summer. I'm also currently looking for funding, and the main things I will use that for will be upgrading components from what I have to higher quality, better working components. To go into more detail about the type of components I'm talking about, there are three main grades of electrical components that I've been able to find so far out in industry. There's hobby grade components, which are more people who want to buy stuff to build products can use. They're really easy to obtain, but they're also the lowest quality. They're also fairly inexpensive. That's the lowest grade. Then the next grade, which a lot of companies use, is industrial grade. So that's a higher quality. A lot of companies use that. And then factories and other products that you happen to find on the market. And then the last grade, the highest one, is military grade, which is in a league all of its own. They're the highest quality, they fail the least often. They're also the most expensive, which, going back to my customer discovery slide, is why I'm choosing to focus on the military last. Because those components are the hardest to obtain, and I have not been able to do so no matter what I've tried. That's also the main reason I'm focusing on thermal imaging, which looks at heat instead of the night vision type that the military uses, which they use a technology called image intensifiers, which I'll be happy to go into more detail about after the presentation. But it was virtually impossible for me to find any image intensifier tubes at the moment. And so in terms of developing or other stuff I'll be using funding for is going to conferences so I can find more customers and people to talk to. And then I will also be looking into patents and IP, which I have not been able to do as much of that as I would like. That is something I am hoping to look for this summer. Speaking of this summer, I will be at the iLab, which is where I am hoping to do a lot more searches into patents and IP, customer discovery, developing a set business plan, and as I mentioned earlier, component upgrades. And so I realized I forgot to tell you who I am. I am Alexander. I am a fourth year with a major in electrical engineering, a minor in design integration through the Technology Leaders Program, and another minor in physics. I've been working on this for several years now, and mostly focusing on the hardware and development in that area. I am currently in the process of looking for somebody who's more focused on the entrepreneurial side of things so I can learn more about that side of the business. Okay, that's all I got.